Welcome friends in our Panasonic robot training how to use the Teach-Pendent. This is the part 23 and here we discuss variable settings. Variables, a quantity capable of assuming any of a set of values whose value can be changed by such actions as substitution, replacement, arithmetic operation, logic operation, etc. in combination with sequence commands. Variables can be classified into two types. One is called a local variable, which can be used only in one program, and the other one is called a global variable, which is common to all programs. It is necessary to specify and register a variable name to each global variable in order to use over an entire system. Note, it is possible to name each variable to distinguish each local variables and global variables. You can see in tabular form. In local variables, variables used in a single program. In global variables, variables used in across all programs. L and an identifier are automatically added to each local variable name G, and an identifier are automatically added to each global variable name. L, 3-digit number. Identifier B, byte. I, integer. L, long integer. R, real number. P, position. L is not attached in front of the identifier P. It is not necessarily followed by 3-digit number. G, 4-digit number. For position type variables up to 999 are 3-digit number. Identifier B, byte. I, integer. L, long integer. R, real number. A, robot. P, position. D, 3-dimensional. T, rotary. Shift. Global variables name, including the identifier, can be changed to any 8 alphanumeric character name. Next table is identifier variable type definition. Identifier B, variable type byte. Definition: 1 byte integer, setting range 0 to 255. If the variable represents on or off, assign 0 for off and 1 for on. I, integer, 2 byte integer, setting range -327682 to 32767. It can be a negative value. L, long integer, 4 byte integer, setting range -2147483648 to 2147483647. It can be a negative value. R, real number, 4 byte real number, decimal fraction can be assigned -99999.99 to +99999.99. It can be a decimal number, including number after decimal point. A, robot, X, Y, and Z position data of the teaching points on the robot coordinate system. It doesn't include positions of the external axis. Use this variable type in a system where the robot is positioned on a shift device when you want to move the robot only to the home position, regardless of the position of the shift axis. P, position. Teaching points including position of an external axis. The teaching points such as P001, P002, and P003 registered in teaching operation are local position variables. D, 3-dimensional, a variable to store XYZ position data such as point, coordinate value, and vector value. Use it for a 3D shift by means of shift on command. T, rotary shift, a variable to specify rotary shift conversion numerically. Use shift on command to execute rotary shift conversion. Next is global variable settings. The number of global variables can be changed with number of global variable settings. Item, description, quantity. GB, unsigned 1 byte, sets 1 byte integer variable 10. GI, signed 2 byte, sets 2 byte integer variable 10. GL, signed 4 byte, sets 4 byte integer variable 10. GR, real number variable 10. GA, robot type variable 50. GP, position type position variable 50. GD, 3D dimensional variable 50. Number of global variables, select it to change the number of global variables. You can see this procedure global variable settings in this image. Set variable. Here you can see item, byte, integer, long, real number of global variables. Window change key switches the active cursor, byte, close. Variable settings, byte. Here you can see variable name GB0001, current value 0. OK, cancel. Setting procedure variable name displays the selected variable name. Current value displays the current set value of the selected global variable. Now next is application examples of variables. Byte variables. One is group input. A byte variable that stores a 1 byte means 8 bits value. When an 8-bit group input is received by the byte variable, the terminals of the group input are allocated to and stored in ones to 1 to 8s of the byte variable as binary number respectively. The value is the sum of the denary number of the digit whose terminal is on. You can see here a table. 8-bit group input D07, D06, D05, D04, D03, D02, D01, D00. Bytes are 128, 64, 32, 16, 8421. Value 0, 1, 21, 106, 255. Example 1, off, all states are off and value is 0. Example 2, all states are off except D00, D00 is on, value is 1. Example 3, D02 and D00 are on and all others are off, value is 2, 1. Example 4, D06, D05, D03, D01 are in on state and remaining in off state, value is 106. Example 5, all are in on state, value 255. If the byte variable is used for 4-bit group terminals, the terminals are allocated to and stored in 1 to 8 second of the byte variable. As for output, 16 second to 120 second are ignored. As for input, 16 second to 120 second are treated as off. Second table shows ignored 4-bit group. Example 1, output value 0, 128 of 64 of 32 of 16 of D03 of D02 of D01 of D00 off. That means all are off. Example 2, output value 1, ignored states are off except D00, all are off. Example 3, output value 21, ignored except 16 are all off. Here D02 and D00 are on. Example 4, output value 106, ignored 6432 on. Here 4-bit group D03, D01 are on. Example 5, output value 255, ignored 4-bit group are all on. Now next is second, logic operation. It is possible to use the byte variable in logic operation. In that case, logic operation is executed on a per bit digit basis. Note, the NOT operation is executed to 8 bits. To execute a NOT operation to 4 bits, execute AND operation to the results of NOT operation and 15 00001111 in binary. Then you can get NOT values only of the low 4 bits. For example, logic operations of byte variables LB001 is equal to 3 and LB002 is equal to 10 are, and logical multiplication LB001 00000011, LB002 00001010, LB001 and LB002 00000010 is equal to 2. Or logical AND LB001 00000011, LB002 00001010, LB001 or LB002 00001011 is equal to 11. XOR exclusive OR LB001 00000011, LB002 00001010, LB001 XOR LB002 00001001 is equal to 9. Not logical not LB001 00000011, not LB001 11111100 is equal to 252. Now next is position variables, a local variable that is created automatically when a teaching point is taught in teaching operation, as they are variables such as P001, P002 and P003. It is possible to change to a result of a calculation and also to reuse them. For example, after moving the robot from P001 to P002 to P003, if you want to move the robot to P001 position again, instead of actually moving the robot to the P001 position again, you can use either re-register or copy a taught point. First, re-register a taught point. After completing teaching of P003, press the enter key once again. Then P004 is registered. Move the cursor to P004 and click it. The change dialog box of the teaching point is displayed. Click the position name. Click Browse button on the displayed dialog box. Click local variable and then click P001. Press enter key to register the P001. Move L P001 7.5 meter per minute. Move L P002 7.5 meter per minute. Move L P003 7.5 meter per minute. Move L P001 7.5 meter per minute. Newly added point. After completing teaching of P003, copy the move command move L P001. Move the cursor to move L P003 line and paste the data. Move L P001 7.5 meter per minute. Move L P002 7.5 meter per minute. Move L P003 7.5 meter per minute. Move L P004 7.5 meter per minute. Pasted point. Note: when copy and paste P001, although the variable name in the pasted line becomes P004, the contents of P004, when copy and paste P001, although the variable name in the pasted line becomes P004, the contents of P004 are the same as that of P001. As P004 is a new variable, changing contents of P001 won't change the contents of P004. You can creatively use those methods. Use the re-register method and keep the same variable name. If you may want to execute batch correction to the variable in the future, use the copy method if you want to treat the copied point independently. So friends, here we end this part of our Panasonic robot training. Further information we will discuss in our next video.